Hello everyone. For this PowerPoint presentation, we're going to be covering the platelets. The platelets, they are these flattened membrane enclosed packets which are going to be round when viewed from above or spindle shaped in a section. And platelets, they were once thought to be the cells that had lost their nuclei because similar functions in vertebrates other than mammals are going to be performed by small nucleated blood cells. And histologists called all of these cells thrombocytes, where thrombos means clot. So the term is still used, and although in mammals the term platelet is more suitable because these are membrane enclosed enzyme packets and not individual cells, so they will not contain a nucleus. Now, normal red bone marrow contains a number of very unusual cells that are called megakaryocytes. As the name suggests, these are very big, enormous cells with large nuclei. And during their development and growth, these megakaryocytes, they're going to manufacture structural proteins, enzymes, and membranes. They then will begin to shed the cytoplasm in these small membrane enclosed packets, and these packets are the platelets that will then enter the circulation. Now, a mature megakaryocyte will gradually lose all of its cytoplasm, and in this process, it will produce around 4,000 platelets before the nucleus will be engulfed by phagocytosis or even by being broken down for recycling. And platelets are going to be continually replaced. So an individual platelet will circulate for about 1 to 12 days before it's removed by phagocytosis. In fact, 1 microliter of circulating blood contains an average of 350,000 platelets. And about 1/3 of the platelets in the body at any moment are actually held, for example, in the spleen. So these reserves can be mobilized when there's like a circulatory crisis that's occurring. So severe bleeding, hemorrhage, things like that. An abnormal low platelet count of about 80,000 per microliter or less is known as thrombocytopenia. And this will indicate that there is an inadequate platelet production or even an excessive platelet destruction. Now, symptoms will include, for example, bleeding along the digestive tract. You can have bleeding in the skin and even occasional bleeding in the central nervous system. Platelets are important because they are one of the participants in the vascular clotting system that also includes plasma proteins in the cells and tissues of the circulatory network. And the process of hemostasis is the process that will prevent the loss of blood through the walls of the damaged vessels. Now, hemo means blood and stasis means halt or stop. So this is exactly what this process will do. It will stop the blood from leaving the blood vessels. Now, don't get hemostasis confused with homeostasis, which is when the body is trying to reach equilibrium to be able to stay stable. So these words are similar, but make sure that you don't get confused. So let's look at this process of hemostasis. So first, there is an injury to a blood vessel that will then initiate the process of hemostasis. This means that the components of the blood will leak out of the blood vessel. So our body needs to make sure that it contains this blood, and it does this by initiating the process of blood clotting. This blood clotting process will involve 3 different steps. First is what we call the vascular spasm, which will constrict the flow of blood. And how will it do this? Well, the smooth muscle that's present in the blood vessel wall will contract near the injury site, and this will reduce the blood loss. And next, there is the formation of what we call the platelet plug. And this means that platelets are going to be activated to move towards the injury site. They are going to be recruited by both chemicals that are coming from the injury site and by being in contact with the underlying collagen. And this will cause the platelets to become spiked or extend these cytoplasmic processes, as we can see here from this image. In addition, they will start to stick to one another. And by doing this, they will be able to temporarily seal the small openings in the vessels. And in the third and last step, we will have the process of coagulation. And in this process, fibrinogen, which will be converted into fibrin, and we saw this already, this will form this mesh of fibers that will trap even more platelets to the injury site, in addition to other erythrocytes. So this process will allow the repair of the blood vessel wall once the leakage of the blood has stopped. So this is how we're able to prevent even further blood loss.